Now, here is the agenda for today's session. The content which I've kept here is for a wider audience. So I'll be talking about what this Industry 4.0 is, what is the difference between Industry 4.0 and Fourth Industrial Revolution, 4IR, and then what are the technologies, key technologies associated in this, and then using these technologies, what sort of research we can carry out, and then finally we'll be concluding the session. So this is the overall plan for today's session. So these are the learning outcomes. First learning outcome is you will understand what are various definitions that are associated with Industry 4.0 and what are the technologies involved. And then what research is possible in this domain. So these are like main outputs from this session. Now, this slide explains the brief history of this different industrial revolution, starting from first industrial revolution going up to the fourth industrial revolution. So the first industrial revolution, which was at the end of 18th century, so main source of power was steam. In the second industrial revolution, which happened at the beginning of 20th century, mass production was the main attraction, and the electrical energy was used for mass production. Industry 3.0, or the third industrial revolution, which came into existence in the beginning of 1970s. Now here programming was the key technology which came into existence. For example, PLCs, programmable logic controllers, or CNC, computer numerical control machines, or programmable robots. So things like that. So all these things came into existence during the third industrial revolution, and programmable devices was the key technology which came. Now, 2014 onwards, we have embarked on another journey, which is now fourth industrial revolution, and it is also called Industry 4.0. Now, what this is and what it is having is, so all the devices and the machines that we developed in third industrial revolution, we are carrying it forward, but now the main technology is all these machines are connected with each other. They can communicate with each other. So connected, now we are talking about connected machines and connected devices, connected equipment. So this is now the essence of Industry 4.0. Now let's go into a factory environment. So here, typically in fourth industrial revolution, it is the we are connecting. So it connects a physical world with the digital world. So we're talking about connected worlds. So you can see what all is happening at different stations in this factory. So for example, at location one, it is robotics. So robotics is involved in fourth industrial revolution. Now coming to the second one, where we have the cloud computing. Now where here data from machines is stored and is processed online in the cloud, so that it can be accessed from anywhere. So this is a cloud computing services. Then we also have big data technologies. So these tools collect and analyze large amount of data from the factory to improve decision making, and that is also part of 4IR. Then we have here at number 4, embedded systems for control and monitoring. So what are these? So these are small computers inside machines that help control their action and monitor performance in real time. Moving further, we have at number 5 is wireless communication. We are talking about connected world. So here is a wireless communication. Now where machines and workers communicate using wireless signals, making system more connected, and we have more flexibility there. Now, coming to the storage part here, now these items are stored in organized and automated way. The system here knows where everything is and manages space well. Moving ahead, next we have is flexible and intelligent logistic systems. Now these systems help move goods around efficiently, adapting to changes in orders or production. Now here, if you might have noticed, here I am using word 4IR. I'm not saying Industry 4.0. So industry, when I say Industry 4.0, then that is a initiative by a German. So that is a German initiative, Industry 4.0. Equivalent to that in China is Made in China 2025. In USA they say smart manufacturing, and each country is having their own equivalent version of this 4 industrial revolution or Industry 4.0. Mostly these terms are used interchangeably, but uh, there is a specific difference, and that specific difference is listed here. Uh, Now, when it is Industry 4.0, so its scope is mainly limited to manufacturing and industrial systems, and it was given by Germany. So, coming to fourth industrial revolution, or in short 4IR, now this covers entire society and economy, and it was given by Klaus Schwab in 2015, who was the founder chairman of World Economic Forum. Now, coming to the core technologies of 4IR, these are some of the technologies, and we will discuss these technologies one by one, starting from additive manufacturing. So, manufacturing can be divided into categories. First one is subtractive manufacturing, and another is additive manufacturing. In subtractive manufacturing, this is something like a conventional manufacturing, where you take example of a lathe machine, where we start with the stock with the help of a cutting tool. We go on removing the material. So we are subtracting the material from the stock to in order to obtain the final shape. Whereas in additive manufacturing, we go on adding the material layer by layer, and finally we build the part. Uh, so loosely speaking, this is sometimes it is also referred to as a 3D printing, but uh, main is manufacturing. It is having two categories: subtractive manufacturing and additive manufacturing. And under additive manufacturing, 3D printing is one type of it. So 3D printing. So in additive manufacturing, we can there are quite a wide range of materials that can be 3D printed. Uh, Polymers, ceramics, metals, and many other materials. So based upon, so there are different technologies also for different materials. And in general, 3D printing is used when the design is quite complex. For example, in this figure, you can see these are the metal 3D printed parts, and if design it is complex, then only we go for uh, additive manufacturing. And this is the one criteria is the part design is complex. The other criteria could be the volume, or if we are going for prototyping. So prototyping could also be manufactured using 3D printing, additive manufacturing. And if we want to go for mass customization, then also we can go for additive manufacturing. And the most the another important aspect is weight. So we can manufacture, say, porous, we can create parts which are having porosity, so we can reduce weight. So when material or weight efficiency we are looking for, then also we can go for 3D printing. But in general, uh, whenever you are deciding between whether to go for additive manufacturing or subtractive manufacturing, you must take into account these criteria, these four criteria, for deciding when to go for additive manufacturing. So IoT. So here we are talking about connected world. So various devices and equipments are connected via Wi-Fi or the devices that we use for internet. So one example we can see here, watch sitting on the wrist can monitor temperature, blood pressure, or heart pulse rate, and then if it is abnormal, it can connect to a hospital and make a appointment with the doctor. So all these things are done automatically without any human intervention. So something similar can also be done in industrial environment. Here you can see this is a 3D printer. Now this 3D printer is sitting in my lab, and I can operate and I can control the 3D printer using my mobile. So this kind of connectivity is possible, and we have successfully implemented it in our lab. So we have connected that 3D printer using Raspberry Pi with the Octoprint. So whatever parameters that we have on the machine, all those parameters now are available on my mobile also, and I can operate, control, and even see the progress of the 3D printer, what it is printing and how much it has printed. So I can put a camera here, and if I put a camera there, that information, that image will also be available to me. So this is how I can make use of internet of things in industry also. So next we have is artificial intelligence and machine learning. Now, so what is it? So artificial intelligence, this is a broad concept. So what we want to make machines that can think and act like human beings. So what human beings do? So we take decision. So human beings are involved in decision making, problem solving, and perception. So these are the things that we want machine should do. Now, when we say AI, so in AI, mainly the AI would include the rule-based systems, expert systems, robotics, natural language processing, vision, and even machine learning. So machine learning appears here. This means now machine learning is one part of artificial intelligence. So machine learning is subset of artificial intelligence. So one example I can give here for artificial intelligence is, so a chess program coded with the rules that always checks best possible moves. That is AI. It is not machine learning. Now, coming to machine learning, as I said, machine learning, it relies on the data, and it learns from that data. So AI, so machine learning is a subset of AI. So machine learns from data without explicitly programming. Now scope is, so focus here, what is the focus? So focus is on algorithm that improves automatically through experience, that is the training data. So one example we can have here is, say, email spam filters that learns from thousands of emails. So that is just one example. So clearly, machine learning is subset of artificial intelligence. So advanced robotics. Now in advanced robotics, we have cobots. Now these are collaborative robots. They work safely alongside humans in a factory. Now they are also AI enabled. So what happens? Robots, they make use of vision, speech, and they learn from all this. And what is the advantage is they can take independent and intelligent decisions, even for situations for which they even for the situations they will encounter for the very first time. So this is the advantage of when you add robotics with AI. This is how it becomes even more flexible. So they can adapt quickly to new tasks, unlike the traditional fixed robots. Augmented reality. So we are adding a digital layer. We are adding a digital layer on top of a normal image. For example, this is the image that I take from my mobile camera, and a digital layer will sit on top of it, and that digital layer will guide me. It will locate what are different buildings, and it will label all those buildings. Then it becomes easy for me to locate and take whatever route I want to take. Now, this is a generic case, but this can be applied to industry also. So, a maintenance engineer, you think like maintenance engineer, that maintenance engineer is taking his or her laptop close to the motor assembly, which he wants to repair. Now, moment he takes it there, then a digital layer which sits on top of the normal layer of the image, it will guide the engineer, and it will tell what are the different parts, where are the sensors located, and if he wants to open it, how it can be dismantled. So it will help the maintenance engineer. So this is just one example how it can be useful for maintenance engineer, but it is having many applications. So augmented reality. There is a reality. I'm adding additional digital layer on top of it so that I'm able to provide extra information about that reality. We are adding extra information on top of it, and this is a digital layer which sits on the top of the normal image. So augmented reality. Something which next we have is virtual reality. So there is no reality, everything is happening virtually. As you can see in this figure, a person is sitting with the headset on, and this guy is performing assembly of some engine or some machine, whereas this machine does not exist physically. So everything is being handled virtually. Now, virtual reality and the augmented reality, they can be combined together, and when they are combined together, they are called mixed reality. So they are called mixed reality, and uh, we have headsets available for Microsoft HoloLens mixed reality headsets are available. We can make use of this to club these two technologies and to take advantage as per our wish. Okay, now we have cloud computing. Now, what is meaning of cloud computing is, so using the internet to store, access, and manage your data and program instead of keeping them on your personal computer. It's as simple as this. So it is not just about storing data. It will also include doing powerful computing tasks over the internet. So if you see this cloud computing, it will include many things. So it will include, say, data storage, and then it was having computing power, web hosting, databases, softwares as service, and then machine learning and AI capabilities also. So lot many things to do there in cloud computing, and these are some of the important uh, cloud computing service providers. Now we have big data analytics. Now here, uh, studying and analyzing a very large amount of data, which is called big data. And why we want to analyze it? We want to find out patterns, trends, and useful information that we require for decision making. Now, when we say it is a normal data and when we say it is a big data, so here is one word, 5V. So this is the abbreviation 5Vs. Now, first V indicates it is a volume. So when volume is huge. Second V is velocity. It is coming at a very fast rate. Third is variety. So different types of sensors are there. And then we have veracity. Veracity means the data is noisy. And then we have, say, the fifth one is value. So we need, value means we need special processing to find useful insights. Uh, so this is, if your data is satisfying this requirement, then certainly it is big data. Uh, for simple example could be, say, if a retail store keeps sales data in Excel, say 1,000 rows, Excel can handle it, then it is a normal data. And if the data is huge, for example, the Amazon store, it is maintaining billions of transactions, clicks, products views, and reviews daily. So this is one example of big data, and for that definitely cloud computing and advanced analytics is required. And we definitely have, there are different softwares that you can use for big data analytics. So there are different categories of softwares, but these softwares we can put them in different categories. First category could be the data storage and processing. The second could be the data warehouse data warehouse and querying. The third could be no SQL database, and the fourth could be data visualization, and the fifth would be machine learning and advanced analytics, and the sixth one would be data integration and streaming. So these are some of the steps, like some of the steps that could be there in big data analytics. And for each step there could be a different software could handle that. So different set of softwares are available for handling different levels of analysis. So this is another important aspect when data handling through internet is involved. So we have security threats. So cyber security is an important concern here. So there are eight main cyber security threats. The first one is malware. Now this is a harmful software that damages or steals data. So the example could be a virus that slows down your computer. And how you can identify it, you will see sudden crashes and strange messages pop up. So what should be doing, you should update your antivirus and do not click on any unknown link. Then we have phishing. In phishing, you will receive fake emails and they will ask you to click on that link. So please don't do that. And then we have ransomware. In ransomware, they will lock your files and will ask for money. So don't pay them. What you should be doing instead is use backup files and then have antivirus installed on it. Then we also have another attack which is called uh, denial of services. So too much traffic makes a site crash. So this is a possibility. And how you can avoid it, you should be using firewalls, or you can use, say, cloud protection. Then we have man in the middle. So man in the middle. So when you transmit data, hackers will intercept and they will take that information. So hackers intercept your data during transfer. So how you can avoid it? You can avoid it by using VPN, so and also avoid public Wi-Fi and use secure and you should be going only to secure websites. Then we have zero-day attack. This is a bit difficult and tricky. Uh, here, so uh, so this is normally before any new. So it's like something new comes up. So these are basically new bugs, and before they are fixed by the company, that data is lost. So it is very tricky and difficult to avoid. So 0 days attack. And next we have is social engineering. So this is a real tricky, it's like a fraud. So tricky people will ask you to give access to your passwords by pretending as if they are employee of the bank or your insurance company. Again, the how you can avoid it is don't share your personal information with these guys. Insider threats, this is also a big challenge because employees, the guys who are working in the bank, they have access to your statements, your financial status. So if they can insiders can make use of that data. And how normally companies tackle this problem, this is a big issue and very difficult to handle. So how they handle it, how they monitor it. So they check like unusual access of sensitive files. If a person is authorized to visit certain data, is he going only on those websites or those databases, or whether he is accessing other databases also. And then copying and moving the data from one location to another location. So all these things can be tracked by the company, and from there they can easily handle this uh, cyber security threat, which is a insider threat. So these are some of the threats. And whenever it is data is there and you want to transfer data over internet, so all these threats are uh, are real threats there. You have to take care of all these things. Now I will discuss a few research topics based upon the latest technologies that are used in Industry 4.0. Now, we can create digital twins for process parameter optimization. What is a digital twin? And this one, the example which is shown here is applied to 3D printing. So we can see there is a 3D printing happening. This is the physical process, real world. And on the right hand side, we have a virtual model. So this is in computer domain, and real time the information is being shared between these two worlds in real time. So that means there are, say, temperature, there are sensors which are mounted on the machine, for example temperature, vibration sensors, and that information is coming to my virtual model. And here, in fact, I can also see, I can monitor what is happening on the machine. I can also see at what level 3D printing is being done. Now, what is the advantage of sharing this information? This is a real-time exchange of information between the sensors. I want to control, I want to focus on the quality of the 3D printed part. So I want to minimize the defects. So in real time, I can monitor how much is the temperature, humidity, vibrations, pressure at the nozzle, and I can link it with the AI so that I'm able to control the process in real time in order to avoid these defects. So that is the goal here in a digital twin. So digital twin is a replica of the real image in the digital domain. That means in my computer domain, and they are communicating with each other in real time. Now, sometimes you may think then it is something like a simulation. Now, a simulation is a bit different from digital twin. Simulation is no doubt it is a predictive experiment, but it happens offline. It is not connected with the real world. Whereas in digital twin, they the virtual model is connected with the real world, the physical process, and they are continuously exchanging information between them. So real time exchange of information, the current status of the machine is known in the virtual world, and I can verify it on the machine. And if I make some changes, if I try to control my virtual model, the same thing will be translated to the physical world. But ultimately, this is there are basically if in normal case you have one physical model, and here in case of a digital twin, the replica of this physical model is available with me in digital domain, and they are all fully connected with each other through sensors and real time information exchange takes place between these two. Ultimate goal is to reduce the defects of the 3D printed part. Now this one is very simple one, a simple example, and it is applied to FDM, but it can be applied to any of the 3D printed machine, mainly metals also, which are quite expensive, and it is worthwhile to see how the metal 3D printed parts are produced without defects. Now, one question comes in mind when I should go for digital twins, because creating a digital twin is an expensive affair. So when should I go for digital twin? Now, I- of course, economics is an important factor. So targeting economics, so you can say if first criteria is you have high value production. Second is frequent downtime of the machine, or there are plenty of defects. The third could be it is the complex line interaction, and there needs to be uh, balance. You need to balance cycle time. You want to reduce, say, bottlenecks, and ultimately you want to optimize throughput time. So you want to optimize throughput time. And the fourth one is remote monitoring. So these are the criteria. If these you satisfy these criteria, then only if you satisfy these criteria, then only you go for creation of digital twins. Now here you might have noticed I have at number three, I'm saying that digital twin can also be created for complex line interactions. That means there are multiple machines, and I can create digital twin of those multiple machines which are available in that line, and that is what research I will show you in the next slide. Now you see here, now AI driven digital twin for smart factories. In the previous slide, it was applied to only one machine. Now we are applying it to number machines in one line if there are 10 machines, and I am applying now digital twin. It is possible to create a digital twins on that entire line. Now what we want to achieve with that, we want to improve the efficiency, we want to reduce downtime, and ultimately we want to optimize our production schedules. So these are important for us for decision making. So we can create digital twins for entire line, or like for entire line, maybe one line or multiple lines. In short, we can say for entire factory also, and this is what is shown here in this research article. And there are certain tools which are available. Now Siemens Digital Industry, Dassault's 3D Experience, and PTC's ThinkWorks Ansys Twin Builder are some of the products that are supporting. They allow connecting multiple assets into one digital ecosystem. So there is plenty of scope in research in this domain also. Another important research topic could be sensor fusion. Now here we can think of we are combining information coming from different sensors and then combining them together in order to make a final decision. For example, autonomous cars is one good example where we go for fusion of lidar, the radar, and the camera images, and then we decide what to do. So we here so in this example, like in this paper, they have they have clubbed vision with the multimodal sensor fusion, and in this sensor fusion what they have included is acoustic emission, vibration, and thermal analysis combined with the vision data, and putting everything together with the help of AI models in order to take a reliable decision. Now, reliability improves when you are relying on more than one sensors, and then you are in a better position to take any decision. Further, this research can be extended for adaptive sensor fusion frameworks that can self-learn and adjust sensor weightings depending on process condition and product type. So lot of scope to work in this domain of sensor fusion. So another topic for research could be digital twin uh, with the AR VR for immersive monitoring. So we are having digital twin of machines, and along with that we are also having IoT sensors, and now along with that this is just one more addition to that, and now here we are adding AR VR headsets to allow operators to visualize real-time factory conditions in a fully immersive 3D environment. The goal here is to improve operator awareness and decision making through immersive monitoring. So it can also help in predictive maintenance and definitely virtual training as well. And this scope can further be enhanced. We can enhance these capabilities to remote factory management, and then cross border collaboration and integration with AI driven analytics for proactive fault detection. So you can see that in every field there is a lot of scope of expansion. So here uh, what is presented to you is how AR VR can be linked with the digital twin, and of course digital twin is also linked with various IoT sensors. Now what is presented here is from this study. Coming to the last part, but it is quite critical part, which is it is linked to information security. So I want to secure my information which I send over internet. So you can use blockchain for securing for secure manufacturing data transmission. Main research idea is to use blockchain to ensure data integrity, transparency, and traceability in IoT and cloud-based environment. Now, what could be the goal here? Now, goal is to enhance security in the data so that nobody is able to tamper with the data, and it ensures trustworthy communication, and if of course it safeguards intellectual property. Now, further again, this can further be and it can further be enhanced by applying it to global supply chains. So, so this is at a local level, and then further you can enhance it at a global supply chain level also. And what is represented here is from this research article. And now it's now coming to the conclusion part. So what we covered here, we saw that fourth industrial revolution, which is ongoing, it's something which is inevitable. Companies cannot say no to it if they want to be competitive. They want to stay ahead of their competitors. Now, industry is ever evolving. It is not that they'll stop at fourth industrial revolution. Even fifth industrial revolution is already into action, and we will have many more industrial revolutions even after that also. That means technology is moving at a much faster pace, especially with the more boost to AI technologies. Industry 5.0, it is more, it is everything whatever we saw in industry 4, that one is carried forward along with the human touch. So that is what is happening in industry 5.0 for the time being, but the technology part is still the same. So uh, so when industries cannot say no to the development. They will have to stay uh, with the technology. As an engineer or as a researchers, we don't have much choice there, so we have to tune ourselves at a pace with which industry is moving. So we have to continuously upgrade ourselves and our skills, and we have to keep on working in new domains of technology which are interdisciplinary in nature. So a lot of scope for researchers to work in this domain, and this is what I discussed here in this session. And yeah, so I would like to conclude this session by this quite important quote, which is quite close to my heart, by Klaus Schwab, founder and executive chairman of World Economic Forum. He says, in the new world, it is not the big fish which eats the small fish, it's the fast fish which eats the slow fish. So you have to be fast at, at embracing the technology, getting in line with the technology, and taking advantage of the technology to the best of your capacity and capability. With these words, I'll be closing this session now. Thank you. These are some of the references